Designed in the final years of the last century with the sole mission of crushing any adversary in the air, there exists a combat aircraft that continues to strike absolute terror into the hearts of military commanders worldwide. Despite having spent more than 2 decades in service, this war machine retains its title as the deadliest air superiority fighter ever built. Its reign is not a matter of chance, but rather the result of a perfect combination of pure physics, radical aerospace engineering, and kinematic capabilities that no other nation has been able to fully replicate. Unlike modern multi-role aircraft that attempt to perform various bombing and reconnaissance missions simultaneously, this heavy platform was conceived with a single obsessive goal: absolute air superiority. The engineers spared no resources and made no design compromises to please different branches of the armed forces, resulting in a jewel of aeronautical technology that remains light years ahead of its closest competitors. If you're passionate about the most fearsome war machines in military aviation, the secrets of advanced engineering, and the physics applied to aerial combat, subscribe to the channel immediately and activate the bell so you don't miss any installments. The first major reason for its undisputed supremacy lies in possessing the smallest radar signature ever built for an aircraft of its size. While other modern 5th-generation fighters and even the latest designs from rival powers must compromise their geometry to carry heavy external payloads or adapt to multiple missions, this fighter bomber was molded millimeter by millimeter to deflect radio waves in every possible direction. Its reflective cross-section, viewed from the front, is so microscopic that to enemy control screens it appears to be the size of a small metal marble or a simple flying insect. This electromagnetic invisibility completely transforms the rules of long-range combat, allowing the craft to operate with total impunity in highly hostile aerial environments saturated with defensive sensors. In an out-of-visual range combat scenario, where engagements are decided before pilots can even make eye contact, this advantage is simply devastating. The platform can detect, track, and lock onto multiple enemy targets at a range of over 100 kilometers, launching its projectiles with surgical precision long before the warning systems of opposing aircraft suspect the hunter's presence in the sky. Behind that geometric shape, virtually invisible to the enemy's electromagnetic sensors, lies the most powerful and impressive mechanical heart ever installed in the cockpit of a fighter jet. The second major reason for its prolonged dominance for over 2 decades at the pinnacle of military aviation lies in the presence of its 2 gigantic, high-performance turbofan engines. These power plants were specifically designed to grant it a superhuman kinematic capability that very few aircraft in the entire history of aviation have been able to sustainably emulate on the battlefield. The ability to fly at true supercruise speed. In the world of conventional military aviation, the vast majority of 4th and 5th generation fighter jets are required to activate afterburners to break the sound barrier and reach supersonic speeds. This mechanical process injects enormous quantities of additional fuel directly into the exhaust pipe to temporarily multiply the thrust of the turbines. However, this resource comes at a huge tactical cost. It depletes the aircraft's fuel reserves in a matter of minutes and generates a massive heat signature that immediately reveals its geographic position to enemy infrared search sensors and heat-seeking missiles. This heavy fighter bomber drastically overcomes that physical limitation thanks to the raw power of its advanced turbines, which allow it to fly continuously at speeds exceeding 8 times the speed of sound, propelled solely by the drive force of its engines, without needing to engage afterburners at any point during the mission. This extraordinary technical advantage translates into 2 simply colossal tactical strengths over contested airspace, leaving any opposing squadron that attempts to challenge it without any effective response capability. First, the ability to sustain constant supersonic speeds naturally grants devastating kinematic power to all the weaponry housed in its internal bays. When the aircraft launches its long-range guided missiles while cruising at high altitudes and nearly twice the speed of sound, the plane transfers a colossal amount of initial kinetic energy to the projectiles. This launch velocity allows the missiles to achieve much greater ranges and maintain a much higher terminal impact velocity against targets attempting evasive maneuvers at distances of tens of kilometers. Secondly, the efficiency of its engines guarantees unparalleled tactical persistence during patrol missions over enemy territory. while rival fighters are forced to fly at slow, subsonic speeds to conserve fuel and avoid running out in the heat of battle. This stealth fighter can move, pursue targets, and position itself at optimal attack angles at breakneck speeds, maintaining an exceptionally cool, discrete heat signature that is imperceptible to enemy infrared-guided weapons. While the combination of broadband stealth and sustained supersonic flight makes it the ultimate long-range hunter, this giant of the skies holds an even more impressive weapon when the battle moves to close-quarters combat or visual duels. In a close-range engagement, where the rules of the game demand sharp turns and immediate changes of direction, the aircraft defies the conventional laws of aerodynamics by integrating its famous two-dimensional steerable vectored exhaust nozzles, capable of pivoting up to 20 degrees upward or downward. In traditional aviation, an aircraft's direction depends solely on the air pressure flowing over the ailerons and tail fins. If the aircraft loses speed or makes too sharp a turn, airflow ceases over the wings, causing an aerodynamic stall that leaves the aircraft uncontrollable for several seconds. The steerable nozzles on this platform break this physical dependence by allowing the engine exhaust to direct thrust independently of the aircraft's nose position. This advanced technology grants it the unique ability to perform aggressive extreme angle of attack maneuvers, known in military physics as the stall regime. While any other conventional fighter would enter an uncontrollable spin attempting such a tight turn, this fighter bomber can almost completely halt its forward motion in the air, spin instantaneously on its own axis, as if suspended on an invisible platform, and point its cannons or missiles directly at the opponent, neutralizing threats that are completely beyond the firing range of other aircraft. The fourth fundamental pillar that has solidified its air superiority over these 2 decades is its ability to dominate the extreme altitudes of the airspace. The aircraft operates routinely and with remarkable ease at altitudes exceeding 60,000 feet, equivalent to more than 18,000 meters above sea level. This flight altitude places the platform well above the standard operational altitude at which the vast majority of 4th and 5th generation fighters in the fleets of rival powers fly. Flying at over 18,000 meters above ground level means operating in a layer of the atmosphere with extremely thin air and reduced density, resulting in significantly less aerodynamic drag. This favorable physical environment not only allows for even higher top speeds with reduced energy expenditure, but also creates a natural defensive gravity shield against any attack from below. When a ground-based surface-to-air missile system or a lower-altitude enemy fighter attempts to launch an intercepting projectile, that projectile is constantly battling gravity and air density to reach 60,000 feet. Adversary projectiles expend almost all their kinetic energy during ascent, arriving at the aircraft's altitude completely exhausted, slow, and lacking the maneuverability necessary to threaten the position of this supreme hunter of the skies. The impact of this aerospace giant on military history extends far beyond its victories in combat exercises or its reputation as the most feared war machine on the planet. The existence of this platform forever changed the defense doctrines of all global powers, forcing its rivals to spend billions for over 20 years attempting to design more powerful radars, longer-range missiles, and fighters capable of challenging its dominance. However, despite the technological advances achieved in recent decades, no other nation has managed to manufacture a fighter that so comprehensively combines absolute geometric stealth, supersonic speed without afterburner, and such extreme vectoring maneuverability. The historic decision to close its production line after building just under 200 units transformed this aircraft into a rare and highly coveted strategic jewel. Each of the units in active service is treated by military commanders as an irreplaceable strategic asset, reserved exclusively to guarantee air superiority in the highest-risk conflict scenarios on the planet. As military aviation moves toward the arrival of autonomous unmanned systems and the 6th generation of fighter jets, this veteran of the skies continues to receive constant upgrades to its electronic architecture, radar-absorbing materials, and communication systems to remain at the forefront of global air power. The legacy of this project demonstrated that true military superiority is not achieved by attempting to build aircraft that can do a little of everything acceptably, but by radically designing a platform specialized for a single task: total air domination. In the world's most complex training exercises, where this aircraft has faced entire squadrons of conventional fighters that outnumbered it 4-1, the results have consistently yielded overwhelming victories without a single casualty, confirming that in modern combat, stealth and kinetic energy are worth far more than the sheer number of aircraft in the air. Although its initial structural plans were drawn up more than 3 decades ago, the physics applied to its design was so advanced for its time that it continues to set the standard for what an elite fighter bomber should be. The combination of its vectored exhaust nozzles, its ability to operate at altitudes exceeding 18,000 meters, and its radar signature equivalent to the size of a simple flying insect ensures that, even in today's technological landscape, no adversary can fly over airspace protected by this fighter without risking immediate and invisible neutralization. The era of aerial combat continues to evolve toward new horizons dominated by advanced computing and artificial intelligence. But the throne built by this milestone of aerospace engineering remains firm and unassailable. 20 years after its first operational flight, the mere presence of a single group of these aircraft deployed in a strategic region of the globe remains the most powerful deterrent to prevent the outbreak of a large-scale conflict. The invisible monster of the skies has demonstrated that when physics, raw power, and geometric design are combined without compromise, the result is a military legend capable of dominating the skies for generations. If you were amazed to discover the real reason why this aviation giant remains the most feared monster in the sky after 20 years and the secrets of its unbeatable engineering, subscribe to the channel immediately. Like this content and share it with your friends who are passionate about military technology so we can continue exploring the future of air power together.